So welcome to particle bounding boxes. What we're going to be doing in this video is getting rid of the horrible problem where our smoke trails disappear when you look at them at a sideways angle, and make sure that they show all the way around like this. So let's go and see how that's done. So this should be a relatively simple and short video. What we're going to be doing is looking at the fact that if you fire a load of these smoke effects into the scene and then rotate your camera, watch what happens. You see them disappearing. They're still there in the world. But as I rotate the camera at about 45 degrees off the camera, they disappear. That's not much fun. That looks kind of silly. So what are we going to do about that? Well, firstly, what's the root cause of it? Let's go into the tank particle system for a start. Sorry, the projectile particle system, the launch blast particle system. Let's go into that. And if you scroll your emitters across and then click in the black space, just to make sure we're on the properties of the particle system itself, not any of the particular emitters. If you scroll down here, I'll give a bit more space. Then one of the things you'll see is that under the bounds section, used fixed relative bounds. And in fact, you can visualize these bounds, this zone in which the particle systems are displayed by clicking on this bounds button here. And you can even click the down arrow and say set fixed bounds. And that will show you, if you've got the bounds on, the zone in which, provided that both the camera and the particle system are in that area, then they will render. And if you see here, it actually tells you the values. The problem is that in our game, when we start moving the camera off to the side like this, we are getting outside of these bounding boxes. Now, it's not entirely intuitive how that's happening. It does look more like it's a problem to do with billboarding, i.e. to do with these textures facing the camera, but it isn't that. That's what I call a red herring. It is just about the bounding box sizes. What it turns out we need, because we have a particle system that spans a very large scale in our game, because the same particle system is leaving smoke over a very long distance in the game. In those circumstances, and in those circumstances only, you don't want to use fixed bounding boxes. You want to turn that setting off. And what that will do is it will recalculate the bounding boxes every frame. Now that will have a performance hit. It may or may not be noticeable on your system. We'll test that in a minute. In fact, it's going to be part of your challenge. But if you turn off this used fixed relative bounding boxes, it's going to, as I say, calculate the visibility requirements every single frame. Now, it's going to warn you that you have a particle system with no bounding box and it contains a GPU emitter. What's a GPU emitter? The sparks are the GPU emitter. They're very subtle. They're hardly any part of the effect, and we can actually just remove that altogether. You can see that it's a GPU emitter because it says GPU sprites here. What that is, by the way, is if you right-click in the emitter, it's the type data is of type GPU sprites. And this means that this particular effect is rendered on the GPU, and it's rendered on the GPU using an optimization based on scene depth. So because GPUs basically can only do things in parallel, and one way to make these types of GPU sprites very fast is to allow the GPU to do it, and different cores on the GPU can do different parts of the scene, but it can only do that if it's all based on scene depth, and that messes up when we start coming to this wide angle. You can see it's already fixed because I've toggled that setting. I can go all the way around now. So what we're not allowed to do is have variable bounding boxes and a GPU emitter, but we don't need the sparks, so I'm going to go ahead and just delete that emitter altogether. So right-click on your sparks, delete it altogether. It'll hardly make any difference to the visual appearance of your smoke trails, but it will stop the warning and make sure you don't get serious performance glitches. So there it is. That is the problem solved. So what I want you to do is remember that you can go to Show FPS here from this down arrow at the top left of your viewport. And I want you to do the following. I want you to go ahead and test your performance impact. Measure your frames per second with 20 smoke trails visible. Turn on dynamic bounding boxes like I just did, measure again, see if there's a change in the FPS, and share your results with the community. If you don't get any change and you don't get anything interesting at 20 smoke trails, then maybe turn it up to 100 if you can click that fast, 100 rounds in the tank, and just see if you can detect how much difference it's making on your system, and then share with us over on the community site, community.gamedev.tv, what sort of impact this is having, this change in setting on your machine. I'll be very interested to see. Okay, welcome back. So there is a small resolution to this challenge. I'm just going to turn on my FPS. I am going to do what I suggested you do, which is you go down. In fact, I'm going to collapse these other guys down so I can quickly get to this. I'm going to use a fixed bounding box, which should be of higher performance because it does not need to recalculate anything every frame. I'm going to fire off 20 of these guys, make sure they're all on the screen, and I'm just capped at 120 frames a second. So I'm on a, what am I on a? Intel i7 4 gigahertz quad core, something like that with a GTX 980. So that's the performance benchmark there. I'm going to suggest that it's capped at 120 frames a second, therefore I'm not going to see any change. So I'm going to need more projectiles. I'm going to go to 200 projectiles. And I'm even going to turn down my minimum reload time. If I'm not even sure I can click a mouse that fast, but it'll allow me to launch these really fast. Now let's put a lot of these guys in the scene. See if I can get the frame rate to drop. It's pretty stubbornly sitting there at 120. You don't want to go too far sideways with the camera because then they're not rendering. But it isn't affecting my frame rate. So on my system, the answer here is it doesn't really make any difference. How many of these things are on the screen? It's not dropping the frame rate. So now let's try going into using dynamic bounding boxes with that many particles. Let's see if we now get a drop in frame rate. I'll even up the screen res by going to full screen. No, you see, even with these dynamic bounding boxes, provided I don't accidentally click on Explorer, I've got full three-dimensional view of these things, and yet I'm still, and as long as I keep my mouse in the game window, I'm still not getting a drop in frame rate. So on my system anyway, it makes absolutely no difference, which is a very cursory proof to me that that's absolutely fine to be using in this game, in this instance. We can use dynamic bounding boxes and still tolerate the performance hit that we are getting. So be interested to see how it works for you. That's all I've really got to say on this video. That is a solution to a common problem. I have also in your slides, by the way, given you a slide that shows you how to do this. It's on the next slide there. It says click here to make sure that you are on the general particle system properties. Go down to bounds and click that. Okay, fantastic. Well done, and I'll see you in the next video.